ITS finished, what happened next?
Right. So at that point, ITS was shut down forever at my MIT, but the files were still available from their FTP site, mostly for the original users to find their old files. But someone picked up and kind of scraped all the files off that FTP site. So
is that someone you?
No, it wasn't. It was before my time, actually. So I'm innocent in this. After that period, there were several PDP-10 emulators that were slowly being made and released to the public. So people started playing around with PDP-10 software and ITS due to these files being available. And that's where I came in. I also started to play around with this. And my first idea was to make an automated build script that installed ITS from tape images, rather than doing all typing by hand. And then I started to add to this build script, so this kind of snowballed and made its way to a complete build script for building and everything from software, from source code. So that's how I started to work on this.
And so you're part of a community at this point, or are you working on your own, or how was it working?
No, we were pretty much a small community working together on this. For example, there's Richard Cornwell. He wrote a KA10 emulator, which is the exact processor used in the MIT ITS machine. And that really got the ball rolling, because then people were starting to add the MIT hardware emulators to this. So we're not only emulating the generic PDP-10, but really the entire MIT lab hardware.
Okay. And so how do we get from that to this replica that you've got here then?
Well, Oscar and I first met in 2019 at VCF Seattle. Do you want to take this part?
Yeah, I guess. And so I've been vaguely aware of this project, but I found it, I was a bit incredulous that it really all worked, and that's particularly because I should maybe show you this picture again. The claim was that it contained all this hardware, right? The PDP-10 and all that sort of supporting peripherals, including the ARPANET IMP and other stuff. So I don't know, I didn't take it too seriously, but Lars said, well, actually, take it from GitHub and compile it. So I went back to my hotel room, compiled it, took 4 hours to compile, actually. And it all worked. And I thought, yeah, this is a huge rabbit hole to sink into. There's this ITS operating system, hundreds of students and people have worked on that and left their mark, left their interesting code. So it's a bit like walking through Pompeii, except they're not ruins, they're actually fully standing buildings. That's kind of how it felt. And we did the PDP-8 and 11 before, so that those were other eras of computer history. But this was like the ultimate computer history capsule. So I decided I wanted to make a replica. But got stuck for 2 years on, it needed to be exactly right. I mean, there's a bit of obsessive compulsive issues here. I first put it into a wooden box, but it didn't look like the KA10 model of the PDP-10, and then we decided, 3D printed is also not possible, so we need an injection mold. But an injection mold of this size is very hard and very difficult, so it took some time to, took 2 years to find the funding and the courage, but it had to be done, so now it's done.
And what's running that? What's behind that? Hardware, software? Tell me a little bit about that.
So it's just a Raspberry Pi behind the panel here. You better use a Pi 5, right? Because there's graphics terminals, there's a PDP-6, there's a PDP-11, PDP-11, some other stuff. But the Pi 5 is powerful enough to run all of it. If you have an older Pi, you focus on a subset. But that's also kind of, there's some poetry there, right? That a $55 microcontroller can run all of this stuff. Massively multi-user, multitasking.
How much would have the original machine have been back in the day?
Millions. Yeah. And in fact, the AI lab with all of this stuff, you talk about a couple of million here, a couple of 100,000 there, a couple of 100,000 there. It keeps adding. It's interesting.
And that's in that day's money or today's money?
That's in those days' money. Right. Yeah.
Fantastic.
But the fun thing for us was indeed to bring it alive, and then we have this sort of idea that these replicas should be computer history capsules. Well, this computer history capsule is the richest you can find. The analogy with the Pompeii ruins makes itself heard. But actually, if you just want to play around, you don't need the physical hardware kit. You can just download the GitHub and install it on a Raspberry Pi, and you will be blinkenless. Yeah, you don't have the blinken lights front panel, but it will work equally well, actually. Yeah. Fantastic. So that's the labor of love. The MIT had 3 of these PDP-10s. Actually, Stanford was also reconstructed. Stanford had a similar setup like ITS. It was called Weights. That's frozen in time in December 1974. So we thought, okay, we have now 3 MIT machines. We have Stanford. We just hook up 35 imps. Then we have an ARPANET. With
So the network...
The routers.
Okay.
Yeah. So other people had already constructed these routers. And so one idea was that we now got this thing running in software. So basically with all this pile of simulated hardware on this ITS reconstruction project, one thing sort of led to the next project, the ARPANET reconstruction project. That's that Lars discovered that on the tapes for the ITS operating system already was the software to drive to connect to an ARPANET, the NCP, Network Control Program. You and Rich Cornwell, I think, then sort of added the hardware to the PDP-10 simulator to actually use that software.
Right.
There was already a whole group and a whole history about simulating the IMP router. That was the crucial infrastructure of the ARPANET, because the ARPANET basically consisted of connected IMP routers. So we now have connected IMP routers talking to ITS on the PDP-10, which means indeed we can reconstruct an ARPANET. But that's kind of its own story again.
The thing that's shoveling in chunks. It's typically much more efficient to grab large swathes, large being like say 64 bytes or 16 bytes of memory at a time, which could be multiple instructions. And so that robot